A sudden burst of radiation just slammed into NASA deep space monitors, and then something unthinkable appeared. Our entire solar system, from Mercury to the frozen edge of the Oort Cloud, is trapped inside a colossal bubble of unknown energy. A structure stretching nearly 1,000 light years, with our sun sitting almost perfectly in its center. This should not exist. Physics breaks, cosmic maps fail, and humanity is left staring at an impossible question. Are we living inside a constructed bubble? And who or what built it? The shock hasn't faded. It's growing. As NASA looks deeper into the colossal structure surrounding us, the more the laws of physics begin to fracture. Instruments across Voyager, Interstellar Boundary Explorer, and Gaia are returning data that no model can absorb. Pressure waves that shouldn't exist, magnetic distortions too large to be local, and a silent force pushing against the heliosphere as if something outside the solar system is closing in. Astronomers expected space. They found boundaries. They expected randomness. They found structure, a structure shaped like a bubble, with us trapped near its glowing center. And now the questions intensify. If this barrier isn't natural, if it isn't stable, if it isn't even ours, then what is holding the universe back on the other side of it? The shock didn't fade. It deepened, because the moment astronomers traced that shimmering boundary encasing our solar system, the instruments that first hinted at it were still transmitting. And their readings made even less sense than the bubble itself. Voyager 1, Voyager 2. Two machines drifting more than 22 billion kilometers from home, far beyond Pluto's orbit, past the heliopause, into the interstellar dark. Both spacecraft carry plasma wave antennas designed to measure charged particles in the local environment. Until recently, those readings matched every expectation. A gentle rise in interstellar density, a smooth transition as solar wind thinned, a stable region. But then, the numbers broke. Between 2022 and 2024, Voyager's plasma instruments detected sudden spikes, brief compressions in interstellar plasma, far stronger than any stellar wind ripple. The pressure curve rose by 30 to 40% in intervals that made no physical sense, and every spike aligned with the same invisible boundary, an edge exactly 500 light-years from the Sun in every direction. A perfect radius, a perfect sphere, something no natural interstellar structure should form. NASA cross-checked the readings with IBEX, the Interstellar Boundary Explorer, and later with IMAP, which was launched in 2025. These spacecraft detect energetic neutral atoms drifting from the edge of the heliosphere. Their maps showed something Voyager could never see, a faint, uniform glow wrapping the solar system, as though space itself had thickened around us like a shell. The temperature of the boundary region, normally around 7,000 Kelvin in interstellar clouds, appeared slightly elevated. Not by much, just a few tens of degrees, but enough to signal compression. Compression without a cause. Before this anomaly, astronomers believed our Sun drifted inside a turbulent region of space called the local interstellar cloud, a drifting concentration of dust and charged gas about 30 light-years wide. It had no rigid shape, no fixed boundary, nothing remotely close to a perfectly spherical envelope. But the new data said otherwise. Spectroscopy from the Hubble Space Telescope, analyzing faint magnesium and iron absorption lines from starlight passing through the region, showed uniform density gradients, microscopic variations that repeated with mathematical regularity. The structure wasn't random, it wasn't diffuse, it was organized. A bubble 1,000 light-years across. And the impossible detail, the one scientists kept checking, rechecking, doubting, arguing over, was the position of the Sun. Not offset, not drifting along one edge, but sitting almost exactly at the center, within a margin of less than 1%. Statistically, the odds of that alignment occurring naturally were so small they were effectively zero. That was the moment astronomers grew nervous. If the bubble were the fossil remnant of an ancient supernova, the Sun should not be centered within it. If it were a cavity carved by stellar winds, it should not be perfectly spherical. If it were a local void created by interstellar turbulence, the boundaries should not emit uniform energetic particles. But all three contradictions appeared at once: the shape, the symmetry, the central alignment. Every part of it violated what astrophysics predicts about large-scale cosmic structures. As IMAP continued mapping high-energy particles, a second contradiction emerged. Magnetic field lines at the bubble's boundary weren't bending naturally. They were bending sharply, as though hitting something rigid, something that resisted the normal flow of galactic magnetism. The deflection angle was small, just a few degrees, but unmistakable. A curvature that shouldn't exist in a diffuse interstellar medium. Planetary modelers started recalculating orbits, wondering if this vast structure exerted any influence on solar system stability. Early simulations suggested subtle gravitational harmonics, tiny oscillations that could explain long-term irregularities in comet trajectories originating from the Oort Cloud, a region nearly 1 light-year from the Sun. For decades, those trajectories had seemed slightly off. Now, astronomers questioned whether the bubble's boundary could be responsible. Even Earth's magnetic field entered the discussion, not because it was threatened, but because the interstellar magnetic environment shapes the heliosphere. And if the heliosphere is interacting with a rigid, structured boundary, then the solar system's magnetic shield is interacting with it too. Cosmologists widened the scope further. If such a bubble surrounds us, is it expanding, contracting, stable? The pressure maps didn't match any known evolutionary models. The density should vary over time, but instead, IBEX detected consistent particle flux for 3 straight years, an astonishing stability for something on a 1,000 light-year scale. That stability scared them most, because stable structures in the universe tend to be bound by something: gravity, magnetism, energy, or processes we understand. But this was stable without explanation. As the data accumulated, tension grew. Weeks of analysis, months of simulations, and still, the bubble refused to fit into any known category of cosmic formation. It wasn't a supernova remnant. It wasn't a stellar wind cavity. It wasn't a magnetic shell. It wasn't a void. It was something else. And then came the readings that shifted the entire investigation. Energetic particle detectors on IMAP began picking up faint rhythmic pulses, subtle oscillations repeating at intervals of 92 days. Not random, not noise. A pattern woven into the very boundary of the bubble. A pattern no model predicted. A pattern Voyager detected too, though far more faintly. No one knew what it meant. Not yet. But those pulses hinted at a second anomaly, one hidden deeper within the structure itself, one that would force astronomers to reconsider everything they thought they understood about the space between stars. And that is where the tension begins to rise, because the next set of measurements didn't just break physics. They broke the boundary itself. The instruments flare again before scientists can even finish arguing over the first anomaly. A second rupture appears in the data stream, sharper, colder, impossibly precise. Voyager's plasma sensor records a sudden drop in particle density, while ESA Gaia telescope detects a faint gravitational pull coming from inside the bubble itself, a pull with no mass, no source, no physics to justify it. Then the thermal map spikes. A thin ring circling the inner edge of the bubble heats by 11 Kelvin in under 4 minutes. No known cosmic structure warms in a perfect geometric band. Nothing natural forms a circle 1,000 light-years wide. Telemetry from multiple observatories now disagrees by fractions of a second. Distances shift, positions drift. It's as if the bubble is adjusting, responding, correcting. This isn't just a boundary, it's behaving like something active. And suddenly every model collapses, because if these two anomalies are connected, the real story is only beginning. The instruments fall quiet again, but not in relief. More like the pause after a whisper you're not sure you were meant to hear. The ring of heat along the bubble's inner wall dims, yet the gravitational echo lingers, steady, rhythmic, almost deliberate. Not a threat, but not random either. And in that silence, a heavier truth settles over every observatory. 2 contradictions, 2 impossibilities, both pointing to something deeper than plasma physics or stellar winds, something woven into the architecture of space itself, a design we never recognized, a structure we never predicted, a reminder that our solar system may not be drifting through emptiness, but through patterns shaped long before Earth cooled, long before the sun even formed. The universe stretches around us, vast and indifferent, yet one faint signal, one shift in temperature, one impossible gravitational pulse is enough to bend our entire understanding. Cosmic laws we believed unbreakable now feel fragile, temporary, subject to forces we can barely measure, let alone name. So we end here, not with an answer, but with a question that grows larger the longer we stare at that 1,000-light-year shell. If the universe is rewriting its own rules, what else is waiting out there in the dark? Subscribe for more cosmic documentaries.